Okay, so we have another question here. This is going to be from 2022 June question number 14 from the Work, Energy and Power playlist. So we have a question here which says a regenerative braking system allows an electric car to use its kinetic energy to charge a battery as the car decelerates. So we are having the kinetic energy of a car decreasing, and as that kinetic energy is going down, it's being converted into the the energy of the battery, okay, to charge the battery. Okay, and the reason the kinetic energy is decreasing is because the brakes have been applied. Okay, so the brakes have been applied, so the kinetic energy is decreasing, the car is decelerating, and that kinetic energy is being converted into the energy to charge the battery. Hope that makes sense. And it says the car is traveling at 13 meters per second and it decelerated to rest. And then the energy transferred to the car's battery during the deceleration was that much. So this is going to be the output. This is what we're looking for. We're looking to charge the battery, and the input for that is going to be the decrease in kinetic energy. So the decrease in kinetic energy is going to be the input energy, and that's going to be half m has been given to us, and then v square. And then the output would be the charging of the battery, the energy gained by the battery, which is going to be 73.9 times 10 to the power of 3 joules. Okay, so this is going to be the output. Now we'll just do output divided by input. So now we're going to do output divided by input, and we're going to get, one second, I messed this up. It should be the other way around. Just give me 1 sec. Okay, so you're just going to do it like this. I realized that I got the wrong answer because my value was greater than 100. So let me just find the correct value. Okay, that's going to give me 56%. Okay, that's the answer to the first one. It's very important you understand this part because this will help us understand the next part. Next it says, as the drag force acts on the car as it moves through the air. Okay, and it says state how the drag force varies with the velocity of the car. So you're going to have to write that the drag force, if you remember the drag force, as the drag force is going to increase, okay, drag force increases because the velocity is increasing. So as velocity increases, drag force increases. You can say the velocity is directly proportional to the drag force. Okay, so that's all for this part, and the above two parts are very important because this is a question in context, and it's very important you understand this question, the above two parts, to answer this part. Now it says the graph shows how the efficiency of the regenerative braking system depends on the initial velocity. Okay, now for initial velocities in range from 20 meters per second to 40 meters per second. So we have different initial velocities, and we're going to have different kinetic energies at the start, and then we're going to see how the efficiency changes with that. So we can notice as our initial velocity is going to go up, the efficiency of the system will go down. Okay, the efficiency of the system will go down. Now, our efficiency of the system goes down if a lot of the energy is wasted energy. Now, where does this concept of wasted energy come from? Well, that has to do with the above questions. As our initial velocity is greater, the work done, or let me just, before I mention that, let me just mention one point. When our initial velocity is greater, our drag force is more. Okay, our drag force is more as the car moves through the air. That's what the connection was. And because the drag force is more, so the work done by the car against drag force increases. So before, the car had one job, that was to just stop. Okay, and all its kinetic energy, or a lot of its kinetic energy, 56% of the kinetic energy went into charging the battery. But now this kinetic energy is not only going into charging the battery, but it's also being lost because the car has to do work against the resistive forces. Okay, so we have to work against the drag force, or the resistive forces, which here would be the drag force. Okay, so at higher speeds, the drag force is greater, so the work done against the drag force increases, and because of this, the energy dissipated increases. Okay, now the energy dissipated is going to be increasing, and because of all of this, a smaller proportion of energy is available to charge battery, and because of this, the energy of the system is going to go down, right? Because remember, its energy output divided by energy input times 100 is equal to the efficiency. Now our energy output is going to go down, so efficiency will go down. Our energy output is going to be going down because now what's happening is that our kinetic energy is being converted not only into the battery to charge the battery, but it's also being converted into the work done against the air resistance. So before, the battery got all of the energy, but now it's getting a smaller value because it's being split. Okay, so because of that, the energy output goes down, so the efficiency is going to go down. So this is the 4-mark question. It's not that hard if you get the context, but I can see it being challenging. Okay, that's all.